Galaxies, planets, comets, asteroids, stars, space bodies are things we can actually see in space, but they make up less than 5% of the total universe. Dark matter, one of the biggest mysteries in space, is the name we use for all the mass in the universe that's still invisible to us.
Be curious. The curious mind discovers treasures in the ordinary.
This enormous unseen component influences galaxies by adding mass and changing motions. We know dark matter dominates because galaxies spin surprisingly fast yet stay intact. Something concealed provides extra gravitational glue. But what is it? Some theorize a hidden zoo of exotic particles passing ethereally through normal matter. Dark matter remains an intriguing mystery, an unseen cosmic constituent rivaling visible matter, detected only in the gravitational pull it exerts across unfathomable expanses as it shapes galaxies. Like an invisible ocean, this dark sea of particles encompasses all we observe, brushing unavoidably but cryptically against visible matter, leaving gravity as its telltale signature.
There's a lot of it. It may even make 25% of the universe. Dark energy makes the rest of the 70% of the universe. Scientists don't know much about it, but they think dark energy could be behind the increasing expansion of the entire universe, while dark matter slows it down.
Dark matter and dark energy differ fundamentally. Dark matter is invisible mass, clustering via gravity and binding galaxies together. It shaped the early universe. In contrast, dark energy permeates space uniformly, its repulsive gravity accelerating cosmic expansion. Dark matter attracts in clumps while dark energy evenly pushes the universe apart.
Dark matter doesn't interact with us in any way that we know of, nor does it interact with itself. If it did, we might be able to find dark matter galaxies, dark matter planets, or such objects.
So in essence, dark matter sticks together and attracts while dark energy permeates everything evenly and separates over cosmic scales.
Now, astronomers have found the largest hole we've ever seen in the universe. It's the giant void that spreads 1 billion light-years across. They found it accidentally. One of the research team members was a little bit bored and wanted to check out how things were going in the direction of the cold spot. That's an anomaly in the cosmic microwave background map, or in short, CMB.
The cosmic microwave background CMB is thermal radiation that permeates the entire universe, believed to be left over from the early stages of the Big Bang around 13.8 billion years ago. When the universe first formed, it was extremely hot and dense with an average temperature of several thousand degrees Kelvin.
It's a faint glow of light that falls on our planet from different directions and fills the universe. It's been streaming through space for almost 14 billion years as the afterglow that occurred after the Big Bang. But instead of CMB, they realized there's a giant area way colder than they'd expected. The team started tracking radio signals, but there were no radio sources in that whole volume. That means there are no galaxies or clusters, and since it's so cold, there's no dark matter either, or regular matter, so it really doesn't matter. The giant void is empty, and researchers think it could consist of dark energy. Light can still pass through it. It's not the only void in space, but it's the biggest one we've found.